Parsa, what time do you have?
Are you in France now?
I am in Greece.
Oh, in Greece. Ευχαριστώ.
I am in Athens. I am in Athens currently. Yes, I am in Athens.
Ευχαριστώ.
Ευχαριστώ. Okay. Thank you
ακριβώς
for
στην Ελλάδα είσαι?
That's my entire Greek.
Okay, that's all you know.
Έχουμε κι άλλον έναν Έλληνα εδώ πέρα.
Ποιος είναι?
Μανώλης Κέλλης, καθηγητής πληροφορικής και τεχνητής νοημοσύνης εδώ στο MIT.
Χαίρομαι.
Χαίρετε.
Parsa, what time do you have?
We're at 9:04. I think we'd be good to.
I think we can start.
Just about get started.
Awesome.
We can start to have, yes.
Yeah,
okay.
and
Awesome.
Dr. Gula, feel free to butt in at any time in the
Welcome,
presentation.
everyone. Okay, I'm going to get us started.
Awesome.
Thank you so much for taking the time to join us here. We really appreciate it. Thank you so much to our advisors. Thank you to the departments at MIT, Harvard, Georgia Tech, and various universities around the country, as well as our esteemed speakers for making it out to this very awesome occasion. I want to introduce our speaker. Professor Joseph Sifakis is Emeritus Research Director at Veramag. He has been a full professor at EPFL for the period of 2011 to 2016. He is the founder of the Veramag Laboratory in Grenoble, a leading laboratory in the area of safety critical systems that he directed for 13 years. Joseph Sifakis has made significant contributions to the design of trustworthy systems in many application areas, including avionics and space systems, telecommunications, and production systems. His current research focuses on autonomous systems, in particular self-driving cars and autonomous telecommunication systems. In 2007, he received the Turing Award for his contribution to the theory and application of model checking, the most widely used system verification technique. He is a member of 8 academies, including the National Academy of Sciences and the National Academy of Engineering. Joseph Sifakis is a frequent speaker at international scientific, technical, and public forums. He is a consultant to ICT companies and public institutions. He is the author of the book Understanding and Changing the World, published by Springer Nature in May of 2022. Without further ado, if we could get a massive virtual applause for Dr. Sifakis. Thank you very much for taking the time to speak with us today.
Okay, thank you. Thank you, Jack, for the introduction. Hello, everybody. It's a pleasure to talk about AI. I'm not an AI person, but I gave a talk this year with this title. And without delay, I would like to start by saying that at present there is great confusion about the final objective of AI. And media and big tech companies spread opinions that suggest that human-level AI is only a matter of years away. So some people talk about artificial general intelligence. This is an ill-defined term. I don't understand what it means, and they don't understand either. I think the purpose is to build super intelligent agents that can outperform humans in particular tasks. I think that AI should have a very different goal. It's building machines with human-level intelligence, and of course we should agree on what it means, human intelligence. But if you open a dictionary, for instance, you will see that being intelligent means that you have the ability to learn, understand, and think about the world, and the ability to act purposefully. And machines can do impressive things, of course, but they cannot surpass humans in situational awareness, adaptation to challenges, and creative thinking. I think it's very important for the scientific community to have a clear idea about what intelligence is. Otherwise, we cannot develop a theory about how it works. In my opinion, today, AI is still in its infancy. It only gives elements to build intelligent systems. It focuses mainly on assistance. Okay, let me take the animation. Okay, so there are 3 different ways to use AI systems. You can have conversational AI assistants like ChatGPT, for instance. But we can have also monitors that are streamers. They receive events and they make predictions or analyze complex situations. And of course, the hardest problem is how to have autonomous AI. In my opinion, AI industry revolution has only just begun. And if we are not successful in building this type of systems, we will fail. My area of interest is autonomous systems. And I think that autonomous systems are the most difficult system to build. They stem from the need to further automate existing organization by replacing humans by autonomous agents. And each agent is pursuing specific goals, but all the agents should collaborate, of course, and exhibit collective intelligence. I hope that you understand the concept. And the realization of the autonomy vision is hampered by non-explainability of AI systems. And at present, there are two different technical avenues to build autonomous systems, either the traditional model-based systems engineering approach and the end-to-end solutions that are AI-enabled, like, for instance, the solutions taken by Tesla. Now, another very important topic is that AI systems are not safe enough. We know this. They are black boxes. So everybody talks about safe AI. We had international summits about that and a lot of discussions. Another problem that is of interest is how to develop what they call aligned AI. So some people would like to consider that AI systems behave like humans, should be evaluated like humans, and they require that AI systems satisfy human-centric subjective properties. Many works talk about AI alignment. If you visit the sites of the big tech companies, they talk about the responsible AI, but we don't understand exactly what it technically means. And I think that although it is legitimate to attribute such properties to AI systems, it's very important to have some agreement on what it means for a system to act ethically, because we don't even understand what it means for humans to act ethically. So the question is what we can say about the risks of AI systems and our ability to control them by guaranteeing their properties. I would like also to make some clarifications, because there is some confusion in the community. We have today, it's clear, two very distinct, different computing paradigms: classical, conventional computers that execute algorithms. Algorithms can be understood and verified, and we have machine learning techniques that produce data-based knowledge. And of course, neural networks are not models. Are just artifacts like software, whatever. And there is some confusion because of that. And I think the best way to understand the difference between neural networks and traditional computers is to consider the two systems of thinking defined by Kahneman. System one, that is fast automated thinking, that is close to neural networks, and system two, that is slow conscious thinking. Something else I would like to emphasize is that neural networks are not explainable in the classical sense, in the classical meaning of the term. What means explainability for a neural network? It means that I can characterize the input-output behavior by a mathematical function, by some model at least. And this is theoretically possible because we know the functions calculated by each node. So this is a kind of, if it is not a recurrent network, theoretically it's possible. However, the approach does not scale up, and I hope you understand this for real life application. Now, there are many papers about that. There are weaker notions of explainability, but they don't provide a rigorous characterization of the behavior. So we cannot, for instance, reason on this model to prove that our system is safe, something like that. Something else that is important to understand is what it means for a system to be intelligent, because also there is a lot of confusion. Many people make reference to Turing test. So the Turing test that consists in comparing a machine and a human into separate rooms with experimental C that sends the written questions and receives answers. And Turing said that if C cannot tell which is the computer and which is the person, then A and B are equally intelligent. I'm mentioning this because many people say, oh, my system passed the Turing test, so it's an intelligent system. The Turing test has been criticized a lot. I will not insist on that, but the success of the Turing test depends on a human judgment that is subjective. So, I mean, it's not a rigorous judgment, and also you can have bias in questions. And of course, intelligence cannot be judged based on a question-answer game because my dog is intelligent, but I cannot play this game with my dog. So in some paper, some years ago, we have proposed this test that we call the replacement test. Is inspired from autonomous systems, where I say that an agent is as intelligent A, and an agent A is as intelligent as an agent B that performs the task if A can successfully replace B. So for instance, I can say that a system is as intelligent as a human driver if it can drive a car, okay? And this is a criterion that I can judge this based on technical criteria. This is a generalization of the Turing test that is inspired. So I think that this is a better test to talk about system intelligence in any case. Now, something else I would like to emphasize is that regarding autonomous systems, which is building autonomous systems is the hardest problem in AI, in my opinion. So being intelligent means that I understand the world and I can make decisions pursuing goals. So the difficulty in situation awareness, you can understand the single domains or many domains, and this is open world situation awareness. I hope you understand this. So humans are here, and then for decision making, you can have single agents and single agents with a single goal, or an agent with many goals. And this is agent intelligence. And what we need, in fact, is to have systems of agents. And for instance, for self-driving cars, if you have systems of agents, you would like that the self-driving cars coordinate to avoid traffic jams, for instance. Okay, something like that. And I think this is something that is important to achieve for autonomous systems, and we are quite far from that. Now, something else I would like to emphasize is that autonomous systems also show that intelligence is a multifaceted concept. There are many different types of intelligence that characterize the ability to perform a task. It does not make sense to say that system S1 is smarter than system S2 if I don't specify the task and the criteria of success. So human intelligence is not a theoretical concept. It's the result of our evolution on a certain planet. And if we have evolved on a different planet, we could have a different type of intelligence. It should be clear. So now, if human intelligence is the benchmark, is the reference for AI should try to build systems that mimic human minds, and can coordinate different human skills. Humans are not very good at executing one particular task, but they are very good at understanding the world and coordinating skills. So I would like to emphasize that today, in fact, there is a kind of complementarity between machine intelligence. So we have machines that are very good at analyzing, at producing database knowledge by analyzing multidimensional data, and humans are not good at that. We know this, but humans are very good at building abstractions and reasoning. And of course, we can imagine that if we combine the two, then we have a being that is super intelligent here. I like this this figure here because, okay, that you can ask many interesting questions. For instance, which problems that humans can solve in a symbolic manner can be solved by machines, in particular by using LLMs. So LLMs have some capabilities to reason, a limited capability to reason, but the question is how far they can go. So this is the end of my presentation. I have a list, an indicative list of topics that we can discuss. Of course, you can ask whatever question you want. And this is also some advertisement about my book and some references. So I will stop here. Thank you.
Thank you very much. So we are going to lead it into Q&A discussion. We're going to have a structured format. So our first topic is going to be human versus machine intelligence, AGI. So our participants are welcome to start posting questions that revolve around this particular subset, human versus machine intelligence. So if your question is around there, we'd be happy to start answering that. So look forward to seeing some very thoughtful questions in the chat. I also have my own questions.
Is it okay
Yes,
to
sir.
ask verbally, or should we only type?
Yeah, I would type it into the chat as opposed to verbally asking. And we, the moderators. So Dr. Moshe Vardi asks, should we build fake humans?
What is a fake human? Okay, I mean, what is a fake human? A kind of phantom of human? I mean, this is a question I cannot answer
Yeah.
technically.
Are you
Yes,
able to elaborate?
because you see, I mean, it's people try to connect AI to humans. Okay, they talk about ethical AI. Okay, but in order to understand what ethical AI means, you should understand how humans choose ethically. So, I mean, there are very complex mechanisms that humans use. They use a value-based system to choose ethically, etc. And these systems we don't understand. So there are papers that claim that, I don't know, this system is ethical, but you don't have any definition. I mean, they judge that it is ethical, it's honest, it's and these are quite superficial papers. It's a pity that scientists sign such papers. Yes.
So
So
Dr. Moshe
I
Vardi
couldn't say yes.
now asks, how about virtual girlfriends?
But you can yes. The question is to what no, but that's a very important question I've been studying for years. And the problem is, that's a very important question. Okay, let me try to explain this. Because, okay, so you say ChatGPT, take ChatGPT. ChatGPT someday, perhaps, will be able to pass final exams in medicine. Imagine this. It's not impossible that ChatGPT passes final exams in medicine. Now, shall we accept that ChatGPT plays the role of a doctor, of a medical doctor? This is a very good question. Think about that. A very important question because it will be posed at some point. Now, because I work on testing AI systems, okay, I know that AI systems are not rational. There is a big difference between humans and AI systems, and this is rationality. So rationality is a very complex context. I'm not going to analyze this. But when I test, for instance, AI autopilots, I see that they are not rational. What it means they are not rational. For instance, an AI autopilot can deal successfully with a very hard maneuver, and if I relax the constraints, it will fail. You see, typically a human will not do that. You have, for instance, exams. I have exams with a level of competence, okay, a level of expertise. If I pass my exam and I become medical doctor, I am sure that I know how to solve simpler problems, okay? And this does not happen. So the issue of rationality of AI systems is very, very important. And I don't know how to even to address this, on how to test this. I'm working on that. But I'm very much excited about this problem, because there are two different ways to compare humans and to compare AI systems, to validate AI systems. Either you judge them as artifacts. So if you judge them as artifacts, you apply the criteria you apply to aircraft, to whatever, and are they safe or not. But you cannot apply testing, rigorous testing to ChatGPT. Why? Because the input and the output is in natural language. So you cannot have rigorous criteria. So the problem that should be posed is whether ChatGPT can be considered as a human. But in that case, we should better understand what it means, what are the key features of a human character and human competence, and then to see how AI systems can approach them. Very hard problems.
So now we're going to
be approached technically. I mean, because you can write papers about ethical AI agents that are empty. Yes.
So now we're going to welcome the audience to verbally ask questions. Parsa, if you want to just kind of observe as people raise their hands, and
yeah, Dr. Kellis, feel free to ask your question. I see that you raised your hand.
Perfect. Thank you very much, Dr. Sifakis. Like, truly a pleasure and an honor to meet you. I'm curious about this perception of self that humans have.
Yes.
And how much that is a construct of our brain versus some sort of deeper self-consciousness construct. Of course, that might be hard to explain, but I'm curious, in your view, when a machine appears to be self-conscious or appears to be conscious of its own state,
yes,
on what basis can we dismiss that as, oh, I know how the machine works and therefore it can't possibly be conscious? Because frankly, we don't really know where the base of our own consciousness is. And the reason why I'm asking all that is that there's a lot of ethical foundations on this concept of self, both for, the rights, of course, and uniqueness of humans, but also for the responsibility of the machines, and also for the ability of machines to sort of act ethically in such a world. So I'm curious what your thoughts are on that.
Good question. Yes. So do you, by the way, do you know any machine that you can say that it is conscious or not? I mean, acts morally. Do you know? Out of curiosity, because I don't know. Just to better understand your question. It's not a trap. It's just a question. Okay, because just to make more specific your question. Okay.
So there have been various reports of people interacting with machines and saying, "Oh, well, I had this feeling that the machine sort of knew what it was talking about or knew what it was, etc." And I've had my own interactions with Claude and ChatGPT and Google AI, where basically you can probe it about its own condition, and it can sort of course, fake it, because I know that it's faking it right now. But at the same time, very often I'm wondering, am I faking it too? When somebody asks me, are you really conscious? And there have been neuroscience experiments where individuals with a severed corpus callosum that does not connect the right side and the left side of the brain shows that our brain will often make up stories to sort of explain the state of its own, where it is, how it's thinking, etc.
Yes.
That makes me question whether consciousness is really something that we should be attributing uniquely to humans or to humans at all.
No.
No.
You can attribute to machines, but you should have a model of what consciousness is, okay? And I'm working on that. I've been working, in my book, I explain some aspects of consciousness. The problem is how to approach these aspects and how to build machines that exhibit this behavior. So let me give you a few examples to illustrate what I want to say. So if I tell you the Earth is flat, am I lying or not? So I tell you the Earth is flat. Am I lying or not? So this is the issue of, yes, am I lying or not?
Are you also a member of the Flat Earth Society like I am?
No, but you see, this is a good question. I mean, so in order to decide whether I am lying or not, you should know what I know. So in order to decide whether a machine acts okay, let me give another example to explain what it means for me to act responsibly. For me, or not to act responsibly. Not to act responsibly means that I do something and I know that what I'm doing is wrong according to some ethical rules. So this is acting not responsibly. So in order to decide ethical issues, examining the external behavior, like we do for traditional systems, is not enough. You should know what the system knows. And I'm writing a paper about that. But also this is something I try to explain in my book. So in order to decide also other properties like rationality, for instance, you should know what the system knows. Otherwise, you cannot make a judgment. And you say that I am a liar just because you know what I know. So in order to say that ChatGPT is not acting ethically, you should know the knowledge that ChatGPT knows and say, oh, he knows this and he tells me something different, okay?
Yeah.
And then this is an ethical issue, okay?
I want to ask
hope
a
this
little
is
bit
clear
because
what I'm saying.
you
Yes.
said if the machine does something that is wrong, but wrong can be illegal, it could be unethical, it could be
Yes.
inconsistent with the goals of the person, inconsistent with the
Yes.
explicit commands of the person, or
Yes.
inconsistent with the limits set up by its own programming.
Yes, yes, yes.
And
But
we
wait
as
a moment.
humans,
So we can have a classification. So if it does something wrong that is technically wrong, this is different. This is, say, violation of some safety property. You can separate the issues, okay? You can separate the technical problem from the ethical problem. The ethical problem, because the technical problem can be just based on technical criteria. I cannot say more here, but I hope you understand what I'm saying.
Yeah.
Ethical problems are just based on the knowledge that has the agent, okay? If I know the rules, so if I kill somebody, or if I did do something wrong, ethically wrong, I will be guilty only if I knew that this is forbidden. Because if you don't know that this is forbidden by law, or if this is against some ethical principles, okay, you can do something. In some societies, you can do something that was not considered as ethical wrong, or ethically wrong is wrong today, okay? It depends on the beliefs of the people, on the background, on the rules, okay? So if you don't understand how agents, humans or artificial agents, choose, okay, make choices, and if you don't analyze also the mechanism that agents, artificial or humans, use to make choices, and that's a very important problem. We should have models about that. If we don't have a model of what the human mind, how the human mind works, I'm not talking about consciousness. Consciousness perhaps is more deep than that.
Yeah.
But we need models. We need models, and we don't have
a tiny point, which is when the machine basically decides to sort of not break rules that we have pre-programmed into it. This falls back into the expert system scenario where we have to, as humans, preempt all of the possible ethical dilemmas, as opposed to the machine itself extrapolating and sort of thinking ethically the same way that we do. So anyway.
Yes. So a machine that does something wrong systematically is a bad machine. I mean, it's a technically wrong machine. So acting ethically means that you have also to choose between, you have a choice, and you make this choice based on some post-benefit analysis, I mean, there are papers about that, but I think we should agree on a reference model. Now I'm working on a reference model, but this model also I explained in my book I wrote 2 years ago. We should have a kind of reference model. you say, and we should agree, how the human mind-brain system works. And in fact, the human mind-brain system combines two systems, and this is related also to Kahneman's system. You have a reactive system, so I receive stimuli and I react immediately, and then I have a proactive system. So a proactive system is I am hungry, so from time to time I'm hungry, and then I have a need, and so this is a system that is asynchronous and is driven by needs, okay? Internal. So this is the self system and the other. Okay, we need to agree on a model. Thank you for the question.
Got it. Thank you very much.
Okay.
Thank you.
Okay.
Absolutely. Do we want to shift to the next
As
topic?
you like, take questions as they come.
Okay.
No problem.
Yeah,
So if we want
I
to
think
shift,
Ben also wanted to ask a question. He was next in raising his hand
Absolutely.
for it.
For sure. Can you hear me?
Yes, yes.
Yep.
Okay. I just wanted to get your input on if an artificial general intelligence system would inherit biases present in human intelligence, as it would also be present in the training data.
Yes. So what's the question about AGI? Sorry.
Oh, sorry. Can you hear me?
Yes, I can hear
If-
you, but I didn't get the question. Yes.
Sorry. If an artificial general intelligence system would inherit biases present in human intelligence, as it would also be.
Sorry, I don't understand what is an artificial general intelligence system. If you can explain to me, I would be happy. Okay, what is an artificial? Because this is a definition that is. I mean, it's not. You see, if I say I want to build a system that matches, that is has intelligence of human level, this is something I can understand because the reference is human level intelligence. But what is the reference? What is the objective for AGI? Can you explain to me? I cannot find any definition of AGI when I read their papers.
Yeah, I wouldn't be able to give one.
Can you tell me?
I could.
I'm very curious. There is no definition. So I think that the idea of AGI, there are some basic ideas behind AGI when I read their papers. One is that machine learning is the end of the story. I don't believe that machine learning is the end of the story for intelligence. You need something else because machine learning is data-based. So I think that at some point you will need some symbolic reasoning if you want to reach human intelligence. So you will need to link data-based and symbolic reasoning. Now, if you discuss with some of the leaders of the AI community, they say, oh, if we build machine learning systems large enough, many trillions, I don't know how many trillions of parameters, then symbolic reasoning will emerge. I don't buy this, by all means. I am an engineer. I don't buy this. So at some point, I think that you should try to combine machine learning and knowledge, that is symbolic knowledge, or knowledge in some memory. An idea I like very much is the RAG architecture. So RAG architecture, you have an LLM and you have some knowledge in a memory. Now, ideally, if we can have symbolic knowledge in the long-term memory of a RAG architecture, that would be fine, okay? But you see, today, AIs can capture some knowledge that is related to the physical world. But there is the world of thinking. And this is, you should be able to bring together the world of thinking and the world of language and concepts, okay, that describes the external world. So this is missing.
Got it. Thank you.
So sorry,
Okay.
if you can refine your questions, because, okay, but AGI, I cannot talk about AGI without knowing what AGI is.
Parsa, do you want to shift to building autonomous systems, agent AI?
Yeah.
But if there are other questions on the previous topic, that's fine.
Yeah, there was one more person who had their hand
Yes.
raised.
Yes.
You're welcome to talk now.
Is that Dr. Belangi?
Or I guess maybe.
Yeah.
Oh, yes.
He just turned on his screen.
Oh, perfect.
Hi.
There we go.
Hi.
It is such a pleasure to hear you, Dr. Sifakis. My question is, now, if it is, in my opinion, it is inevitable that including safety critical systems, that we may have some components that are inspired by AI-based, systems, AI-based
Yes.
models. In
Yes.
that case, how do you verify such systems and guarantee, behavior in such systems?
Yes, that's a good question. Yes. Okay. So you cannot verify such systems. It's obvious to me. I mean, if you have AI components, you cannot verify because AI components don't have models. I think the interesting approach is to have an architecture. So to start with an architecture that depends on the problem you want to solve. So I believe that architecture is the solution. Typically, for instance, for AI agents, all the papers now that talk about AI agents present some architecture that combines different functions. So a perception, a reflection, decision-making, planning, whatever, has some memory there, etc. Now, if you believe that this is the good architecture, and this is something they don't do so far, these papers, you should explain not only the functionality of each box, but how they cooperate to produce the autonomy, to exhibit autonomy. Now, I believe that if you have such a good architecture, then you can verify separately the components. Let me tell you what I'm doing with self-driving cars. Self-driving cars, they have perception. They have perception, but the perception module is connected to a map because the user should specify in the map the road, okay? So if now I consider the problem, I have the map, the road, and the positions there, and the decision-making problem, testing this becomes a technical problem because everything is expressed in physical quantities, okay? So this can be tested, at least, cannot be verified, but can be tested, okay? So I believe that let's agree on architectures depending on the problems we want to solve. But you see, a good reference architecture is composed of functions that are independent, are orthogonal somehow. Because I see architectures where you have just boxes, okay, just PowerPoint boxes, okay, and you don't understand what they are doing, and there are overlapping functions. I mean, this is bad architectures. So, but if we agree on a functional reference architecture for AI agents, for instance, then we can reason about that. And this can be a reference also for building correct systems. And also the reference architecture, the components will be mathematically defined. Now, if somebody wants to implement a box using model-based technique or neural networks, he's free to do that. Okay, so I mean, I believe that the solution is architectures. And then, of course, testing or compositional reasoning for components we can verify.
Okay, thank you very much.
So Dr. Sifakis, I just want to be mindful of your time. What time, again, do we have until, just so we can make sure that we're...
The question is to me?
Yeah, I just wanted to...
No, I have no problem. I have no problem of time. As long as there are questions,
I just wanted to make
people
sure.
want to say yes. No problem. No problem on my side, yes.
Okay. Do we have any other questions on this particular human versus machine intelligence AGI? And raising the hand is the best way to get our attention. Parsa, do you see any hands raised?
I don't see any currently raised.
Then we're ready to move on to the next topic of building autonomous systems, agent AI. So we welcome questions surrounding this area. So if you have a question for Dr. Sifakis regarding building autonomous systems, agent AI, please feel free to raise your virtual hand, and we will get to you.
And it can really be about any of the topics. I'll drop all of them into the chat as well.
Okay.
Just in case folks have forgotten what topics we're
Thank you.
discussing today, and we can get.
Okay, yes. Take the questions as they come, yes.
Parsa, you see any hands raised? If
No, it doesn't look like it.
okay, I mean, I have a question if no one else.
Yeah, go for it. I mean,
okay. So one of my questions, Dr. Sifakis, is what do you see as like the biggest challenges in designing like fully autonomous systems that can like operate reliably in unpredictable real world environments?
I mean, this is a very hard problem. I don't know how to solve it.
Okay.
Yes, but let me say something about that, of course. So today we have some partially autonomous systems that are experiencing some difficulties. Remember, 10 years ago, some people were promising fully autonomous self-driving cars by 2020, and this did not happen. And it's likely not to happen in the next, perhaps, I don't know. I mean, it's very hard to predict because the problem is very hard. A hard problem is how to link sensory information with symbolic information. So there is a problem because you are sensing, and then you have to use at some point some map, and you have to connect the two. Okay. And you should make an analysis in an unpredictable environment. So there are two approaches, as I said. One approach that is followed, I mean, the classical approach. You build an architecture, you have a perception module, a decision-making module. Okay, you try to integrate them into an architecture. And this approach, okay, works more or less. So, for instance, Waymo, we know that they have some problems with their robotaxis. And the problems are not only safety problems, it's problems of social intelligence, for instance. They should let a police car pass, okay? They should not block, or they should behave socially somehow. And this is something they are discovering now. The other thing I will tell you about robotaxis is that their speed is limited. So in the experiments we do with higher speeds, we find a lot of problems. And also there are some limitations. I mean, they are perfectly good in San Francisco, where you have streets with straight lanes, traffic lights, etc. Now, if you let them travel in roundabouts, mergings of roads, etc., the problem becomes, and this is something we see in simulators. So we're far from having a solution to that. The other approach that is taken, that is end-to-end AI approach, there are some companies now that get funding for that, you know this. And I think that at least the open source autopilots that are end-to-end AI have similar problems, have a lot of problems when we test them. So the reason is obvious, okay? I mean, I don't believe that a fully an end-to-end AI solution will work, because one reason is that you cannot test it already. And I explained the lack of rationality of these systems. They can drive perfectly in a difficult situation. So you test it in a difficult situation, it works well. And for some ridiculously simple situations, it does not work. So there is a problem of testability also of these systems. We are quite far from having something that is satisfactory from a safety point of view.
And then Hong, you have a question.
Sorry?
Yeah. Thank you so much for the talk in the first place. Can you guys hear me?
Yes, I can hear you.
Okay, awesome. Yeah. So I agree with the fact that AGI is not defined, but I see this more of as an opportunity rather than a bug, right? As a researcher studying AI myself, it is up to us to build AGIs and define what they become. And along these lines, I want to ask do you have a personal vision of what you think AGI should become and how we should develop AGI to be useful and also practical for humanity in general. And along
Yes.
these lines, do you have directions, immediate directions that you believe we should explore to further this goal, right?
Yes. In order to give you an answer to this question, I will try. But first, can you explain to me what's the difference between AGI and uh, human level intelligence? So if I have a machine that has a level of intelligence that is close to human, what it means, because I explained the idea of the replacement test, I can replace a human agent by this machine and will solve the problem. Is that AGI or not? Because I think that in AGI, people are trying to solve very special problems and they are doing very well. It's impressive what they are doing, and there's no surprise because humans are not very good at solving particular problems. Okay,
Yeah,
so you can have an AGI that solves a problem in I don't know, geometry, in physics. I don't know. I mean, but the problem that what we should agree on what is the objective of artificial intelligence. Is the objective of artificial intelligence to build the machines that, I mean, we are considering that the reference for intelligence is the human intelligence or something else? This is the question. Now, I think, yes. Is it clear what I say?
Yeah. And I have a follow-up question. So you say that about AGI, and I agree, right? We already have systems that are very useful. However, you still mentioned that you don't think data-driven models are what we should be developing to reach the AGI goal. And I think that conflicts in my mind, and that's kind of what I wanted to ask.
No. What I said is that machine learning is not enough to have machines that exhibit human level intelligence. That's what I said. Human level intelligence. This is the reference. If AGI has a different objective, you should tell me what is the objective of AGI. I don't know. So because the objective of AGI should be defined in some technical manner. I think that if you consider human intelligence as a reference, then you say, oh, well, I want to build machines that mimic humans to some extent in doing something or can perform as humans in solving problems. So either the reference, because there are two approaches here, and this is a matter of choice, of objective. Either you say the reference is human intelligence, let's build machines that exhibit human intelligence, and I understand what it means. This means, or you say that the purpose is AGI, but just tell me that it's a different kind, because I can imagine that there are different kinds of intelligence. For instance, you can create some artificial environments, so in virtual reality, where machines can navigate or can understand better the world than humans, okay? And that's perfect. But so I agree, intelligence is not, human intelligence is something that emerged under some conditions, and we have some characteristics. For instance, humans cannot understand the relations involving more than 5 parameters. There is a limit that is cognitive complexity. We know this. And machines can deal with phenomena where you have thousands of parameters, no problem. Okay? So machines are much better than that. So we should agree. I have nothing against AGI. The problem with AGI is that people talk about AGI without giving a specific goal to AGI or specific goals, technically defined. I mean,
so let me put it this way, right? And you can correct me if you think I'm wrong, but the way I see it is that there's a reason that humans developed the intelligence that we developed, right? Yes, we have limitations to this intelligence, but we developed it so that we are better fit to survive in this environment. And the reason we should pursue this kind of human intelligence and of course, even venture into the superhuman level is because we want helpers to help us further our adaptability to our environment, right? And this is kind of how I see it, and this is why I think AGI should pursue a similar level of intelligence as humans, and furthermore,
So now you give a definition of AGI. You say we go beyond human intelligence
in the human manner, right? Yeah.
In the human manner. Okay. Okay. I guess. But I would be happy if I had some more precise technical definition. For the moment, I'm trying to characterize human intelligence by developing, as I said, a reference model of an agent, an intelligent agent.
I see. Okay, thank you.
Okay, thank you.
So the next question is, does anyone have anything related to AGI before we move on to building autonomous systems?
Just take the questions as they come now.
Okay.
Because time is passing.
Gotcha.
Yes, okay.
Okay.
Yes.
Next question. Does anyone have a question? Okay, I have a question. So, given the increasing complexity of these AI systems, how can formal methods be used to ensure robust risk assessment and validation, especially in safety critical industries like healthcare, finance, and autonomous driving?
Yes. Okay. Good question. So in my papers, I distinguish between technical systems and non-technical systems. Let me try to explain this. Technical systems, inputs and outputs are defined, have values, say, physical quantities, something like that. So if you use an AI in medicine, it receives values from sensors. Okay, if you know the meaning of these values, then you can test technically. Now, ChatGPT, you cannot test. Okay, so there is a limit. There is a difference between technical and non-technical. Okay. So if you have systems that deal with natural language or with have sensory information you cannot interpret rigorously, then of course you cannot apply formal methods. Now, formal methods, what it means formal methods? Verification you cannot apply to AI systems, so you are limited to test. And for test, you need some theory. Let me give you an example. So you've probably seen in publications some company, they say we've driven more than 10 billion kilometers or miles in simulation, so our cars are safe. This is technically, this argument is completely empty. Why? Because if you have a theory of testing, and this we know from hardware or software testing, you need also some criterion of coverage. Because you've driven 10 billion kilometers, but in which conditions? Are you sure to cover all the important situations? So you need a theory. And currently we have a theory, I've worked on theory of testing of hardware or software, but for self-driving cars, we have no theory of testing. What it means that I have a good coverage. You have scenario-based testing, for instance. But then you can argue, what is a good coverage criterion? You need some theory about that, and we don't have this. So just to finish, to summarize, for technical systems, we need some theory, and the theory will be limited in testing, which means that if we are limited in testing, we will not have the strong guarantees we have, for instance, for aircraft. I have worked for aircraft, but for aircraft, we use model-based techniques, and you can guarantee, for instance, that the reliability of a flight controller is of the order of, of the order of 10 to the minus 9 failures per hour of flight. And you have this is a discussion you have in the certification process. You say, I guarantee that I will have no more than that, okay? Because you are model-based. Now, if you apply test only, not verification, this means that you cannot provide the type of guarantees for technical systems you provide for classical, for conventional safety critical systems. Okay, yeah, I hope this is clear. Now, for the other systems like ChatGPT, then the question is whether you consider them as humans, human agents. But I discussed this already. You should have some rigorous technique to do that.
And then Noah.
There is another question here.
Noah Aritsky.
Hi.
Hi.
So there's a lot of experts in the field here, and I wanted to ask, as an undergrad who does not know much, what are your favorite resources? What would you recommend looking into to learn more about artificial intelligence?
Oh, I'm not an artificial intelligence person. I'm not very well positioned. Sorry, I will not provide an answer to this question. You should find experts, AI experts. So I will not give any advice because my knowledge is rather superficial. Yes.
Autonomous AI systems.
Sorry. I cannot answer this question.
Mm-hmm.
Okay.
Does anyone else have any questions? If you guys have questions, if you want to verbally raise your hand.
It looks like somebody's, asking the same question, but specifically for formal verification.
Sure.
Yes, but I think I answered this question. So yes, despite what is said in the literature, so you have some papers that try to apply verification techniques to AI systems. So the idea is to try to extract models from the neural network by applying some abstraction techniques. Yes, but these techniques do not scale up. You see, it's not impossible. Theoretically, it's not impossible to find to extract models, but the complexity is overwhelming, so it will not work in practice. And of course, there are many other papers that take a notion of explainability that is very, very different. Okay, and I mean a much weaker notion of explainability that does not help if you want to verify safety properties, for instance.
And then Dr. Balaji, you also have another question. You're not. You're on mute.
Sorry, Dr.
Yes, I can hear you. Yes.
I mean, my literature knowledge is not very broad in this, but nevertheless, even when we have certified aircraft systems, right, for guaranteeing the behavior of such systems, at the end of the day, if it is a human, that is operating the system, we still believe, our society believes that the system is running correctly because it is certified. Can't we extend the same kind of approach when you have an AI that is interacting with a certified system and when we want to verify or guarantee the properties of the system?
Yes, I think I have replied to this question. Yes, so it's as long as you are model-based, because all the standards. The standards, you have this V model, the famous V model, and all the flow is model-based. What it means, you start from requirements, you analyze the requirements, and you understand, you justify what you are doing, you document all the design flow, etc. And then the certification authorities, based on that, they say, this is a good system, okay? And I worked for Airbus on this kind of systems. I know very well the process. Now, if you have an AI, the problem is that you cannot say anything. You cannot provide any evidence. The solution would be, there are solutions. We can still use an AI if we have a hybrid solution. The hybrid solution means that I will have a model-based system. So these are solutions that are being developed by some automotive industries. So Assume that I have a very smart AI autopilot. It knows how to drive in I don't know, 99 point something % of cases. Then you can have run in parallel a model-based solution that is robust, you have certified, and so you have what some people call runtime assurance architecture. So this is an idea also you have in avionics. NASA are using this, okay? No, runtime assurance architecture. The idea is that you run them in parallel. And when there is, for instance, some possible collision, you disconnect the intelligent system and you have the other system that is reliable. The problem, of course, is the transition between the two systems. And the idea is that when the AI system recovers, then the robust system gives back the control. Of course, you don't want to have interruption of service. And this is the hard problem, because the simple problem is to run them in parallel, and we have such solutions also in critical systems. You stop. But you don't want to stop to have discontinuity of the service, and this is the hard problem. But I think this is a viable solution for automotive systems. Okay.
Yep. Thank you very much.
Thank you for your question. Okay. Are there any final questions before we wrap things up? Going once, going twice. Okay. Dr. Sifakis, I really just want to say thank you so very much for your time. We really appreciate it. We hope to figure out some way. We usually give a speaker gift. Last year we gave chocolates, Godiva chocolates to our speakers. If we can figure out a way to get it sent overseas, we'd love to work with you on.
I don't need any gift. Okay. I mean,
okay.
For me, it's a satisfaction that I could participate to this discussion. And yes, okay, that's fine. Thank you.
We just really appreciate your time. We look forward to staying in touch, and we really appreciate everyone that took the time to come out here today for the first Turing Mind session. Next week we have Dr. Leslie Valiant giving a talk, and thank you everyone for your time, and I hope everyone has a great weekend.
Yeah, thanks everyone for joining us,
everybody.
especially Dr. Sifakis. Take care, everybody.
Bye, guys.
Bye-bye.
Bye. Thank you. Bye.
Thank you.
Bye. Take care.
Bye.